Hello students, and I welcome you all in this in my online class. So today I am doing class for class 12. The topic is the same topic, that is matrix. In the last online class also we were doing the same topic, that is matrix. So today we will do questions from previous higher secondary question papers. Okay. The question is from HS 2015. Question number 1B number 1. If the matrix A is equal to first row 3 1, second row 7 5, second order matrix is given, and capital A square, that is capital A is matrix A whole square is equal to minus xi plus ya. Find x and y where I is a unit matrix of order 2. So here x and y are the unknown quantities. You have to get their values, and here what is I? I is the unit matrix or ideal matrix of order 2. So this matrix is given as 2 cross 2 matrix, that is 2 rows and 2 columns, and the equation is given here: a square is equal to minus xi plus ya. This is not as a matrix equation. Using this matrix equation you have to get the values of x and y, right? So here given matrix is a square is equal to xi plus ya. So it is minus, this is your minus xi plus ya. It is given as minus xi plus ya. Okay, what is a square here? A dot a is equal to minus xi plus ya. Or what is capital A out here? What is capital A? So it is given as the first bracket, so write it within first bracket. So if it is given first bracket in the question, you have to write first bracket. If it is given within third bracket in the question, you write within third bracket. Okay, so 3 1 first row, second row is 7 5, and what is A again? It is 3 1 7 5. So which is equal to minus x. What is I? I is the unit matrix of order 2. You know unit matrix, that is 1 0 0 1. So write it within first bracket. This is 1 0 0 1, right? Then plus y. And what is A out here? What is A? It is 3 1 7 5. So now you know how to simplify it, isn't it? You have to multiply these two matrices, 2 columns and 2 rows. Same number of columns is equal to number of rows, so you can multiply them row by column. You have to use row by column. Row by column, multiply row by column. 3 3s are 9, 3 3s are 9 plus 1 7s are 7. Again first row by second column, corresponding elements should be multiplied. 3 1s are 3 plus 1 5s are 5. Okay, now second row by first column, 7 3s are 21 plus 5 7s are 35. Next, second row by second column, 7 1s are 7 plus 5 5s are 25, right? So which is equal to, now multiply by minus x here. Minus x is the scalar multiplication of this matrix, so which is equal to minus x 0 0 minus x. Okay, plus, now multiply by y here. It is 3y, this is y, right? This is 7y and this is 5y. So is that clear to all of you? So now let us simplify it further. Now you can add these elements here. So next, or 9 plus 7 is 16, 3 plus 5 is 8, 21 plus 35 is, this is your 56, this is your 56, 7 plus 25 is, this is 32, right? And the next one is equal to, you can add those two matrices because they are of same order. So minus x plus 3y, minus x plus 3y, next 0 plus y is y, next 0 plus 7y is 7y, then minus x plus 5y, minus x plus 5y. This is your minus x plus 5y. Okay. So now, these are the equality of two matrices. You know, from the definition of equality of matrices, you can equate the corresponding elements. From the definition of equality of matrices, we can equate the corresponding elements here. That is, from the first row, you can equate first element is equal to first element, second element is equal to second element. From the second row also, you can equate the first element is equal to first element and second element is equal to second element. So therefore, you can equate 8 is equal to y. That is 8 is equal to y. That means we get the value for y. Y is equal to 8. You can equate 56 with 7y also. In that case also, y is equal to 8. That is correct. Okay, so we have got the value for y, which is equal to 8. Now you can equate minus x plus 3y with 16. You may equate minus x plus 5y with 32 also, so that you can get the value for y using so that you can get the value of x using the value for y. Okay, so or minus x plus 3 into what is y here, 8, which is equal to 16. Now you can solve this equation to get the value for x. This is minus x plus 8 3s are 24 is equal to 16, or minus x is equal to 16 minus 24, or minus x is equal to, this is your minus 8. Is that clear? 24 minus 16 is 8, but you have to write down the sign of the greater number, that is minus 8. So here minus 8 gets cancelled, so x is equal to 8. So what is the answer here? The answer is x is equal to 8, y is equal to 8. So this is the final answer. So I think you have understood it. So this question carries 2 marks. Okay. So now we'll do the next question. Now we'll do the next question, that is from the same question paper, HS 2015, but this is question number 2B number 1, and this question carries 4 marks. Okay, so 2B number 1 is, if capital A is a matrix, if the matrix A is equal to second order matrix is given, that is in the first row 1, 4, and in the second row 2 and 3 are given, then you have to show that a square minus 4a minus 5y is equal to theta. Here I is the identity matrix of order 2, that is 1, 0, 0, 1, and theta is the null matrix, because all the elements here are 0, 0, 0, 0, 0, right? And using this, first of all you have to prove this relation, a square minus 4a minus 5y is equal to theta, and using this relation, you have to find out A inverse. Is the question understood? Now here matrix A is given, that is 1, 4, 2, 3 square order matrix is given. You have to show the relation a square minus 4a minus 5y is equal to theta. So let us show this relation first. And using this relation you have to find out the matrix A inverse. Okay. So LHS. So write down LHS is equal to a square minus 4a minus 5y, which is equal to, what is a square here? A dot a minus 4a minus 5y, right? What is a here? What is a? It is 1, 4, 2, 3 is a. Again, what is a? Repeat it. 1, 4, 2, 3, right? So minus 4 into, what is a? Again, write down. It is 1, 4, 2, 3. Then minus 5, it is 1, 0, 0, 1. Is that clear to all of you? So we are using the values only out here. Now you can simplify it further. Now you can multiply them. First row by first column, corresponding elements should be multiplied, and you have to write it here. 1 1s are 1 plus 4 2s are 8. Right? First row by second column, corresponding elements should be multiplied. 1 4s are 4 plus 4 3s are 12. Right? Again, second row by first column, corresponding elements should be multiplied. 2 1s are 2 plus 2 3s are 6. Again, second row by second column, corresponding elements should be multiplied. 2 4s are 8 plus 3 3s are 9. Right? Now, 1 4 2 3 is the matrix A. All the elements of the matrix A should be multiplied by the scalar quantity, that is minus 4. So you make it plus and multiply all the elements of the matrix by minus 4. Minus 4 minus 16 minus 8 minus 12. Right? Then write on plus out here. Okay? Again multiply by minus 5 here. You'll get minus 5 0 0. This is minus 5. So is it understood now? Now we have to simplify it. So let us simplify it. Which is equal to, what is 1 plus 8? 9. 4 plus 12? 16. 2 plus 6? 8. 8 plus 9 is 17. You can add those two matrices because they are of same order. Plus minus 4 minus 5 minus 9 minus 16 plus 0 minus 16 minus 8 plus 0 minus 8 minus 12 minus 5, same sign, you have to add them, so you will get minus 17. Right? So next, in the next step, you can add those two matrices. 9 minus 9 0, 16 minus 16 0, 8 minus 8 0, 17 minus 17, that is also 0, which is equal to, by question, it is theta. So we have proved the first part. So theta is proved. So I think you have understood it. So this is your first part. Now hence, using this relation, you have to find out A inverse. Okay? Now write down the relation and that we just proved. The relation we proved here is, now A square, then minus 4A minus 5I is equal to the null matrix, that is, it is given as theta. So what is A square here? A dot A minus 4A minus 5I is equal to theta. Since you have to get the matrix A inverse, you have to multiply both the sides by A inverse. Right? So multiplying both the sides by A inverse. So what do we get? A inverse AA, right? Minus 4 A inverse A. Now minus 5I is there. So minus 5 A inverse I, which is equal to, on the right hand side, A inverse theta. A inverse theta. And now you have to use the properties of matrices now. So what is A inverse dot A? I told you about this. What is A inverse dot A? That is IA minus 4. What is A inverse dot A? That is always I. Minus 5, you know this property, A dot I is equal to A. Likewise, A inverse dot I is A inverse, which is equal to, what is A inverse dot null matrix? That is your null matrix. Like 2 into 0 is 0. Similarly, A inverse dot theta is your null matrix, that is theta. Right? Or what is I dot A? That is your A. Minus 4I. Now since you have to get the matrix A inverse, take that minus 5A inverse to the right hand side. So what does it become? Theta plus 5A inverse. Okay? Now on the right hand side or on the left hand side, you can use the value here. What is the matrix A? 1 4 2 3. It is 1 4 2 3 minus 4. Then what is I? 1 0 0 1 1 0 0 1, right? And what is theta plus 5A inverse? This theta means it is just like your 0. So 5A inverse plus 0 is 5A inverse plus 5A inverse. Okay? Now simplify the left hand side. First matrix remains same, 1 4 2 3. Then make it plus sign. Now this minus 4 is the scalar multiplication of that identity matrix, and all the elements of the identity matrix can be multiplied by minus 4. So what do we get? minus 4, 0, 0, minus 4, which is equal to 5A inverse. Now add those two matrices. What is 1 minus 4? Minus 3. 4 plus 0, that is your 4. 2 plus 0, that is your 2. 3 minus 4, that is your minus 1. 1 minus 4 is minus 3. 4 plus 0 is 4. 2 plus 0 is 2. 3 minus 4 is minus 1, which is equal to 5A inverse. Okay. Now we have to get the matrix A inverse. Now we can take this 5 to the left hand side. When you take this 5 to the left hand side, you should write it in the denominator. That means it becomes 1 by 5. 1 by 5, so it is minus 3, 4, 2 minus 1, which is equal to A inverse. Now you can write A inverse on the left hand side and this matrix on the right hand side. So what do we get? Therefore, A inverse is equal to, multiply all the elements of this matrix by 1 by 5. Multiply all the elements of this matrix by 1 by 5. So what do we get? It is, multiply minus 3 by 1 by 5, minus 3 by 5. Right? Next, 1 by 5 into 4, it is 4 by 5. Next, 1 by 5 into 2, 2 by 5. And the last one is minus 1 into 1 by 5, that is minus 1 by 5. So this is your answer. So we have got the matrix A inverse from the relation A square minus 4A minus 5I is equal to theta. Okay. So this is very, very important question. You can practice it at home. Now we'll do the next question. So now we'll do the next question, that is from Higher Secondary 2016, and this question carries 4 marks. So this question is from 4 marks section. So 2B number 1, solve by matrix inversion method. So you have to use matrix inversion method to solve this given system of linear equations. Okay. So I told you that always you have to keep the constant term on the right hand side. Constant term means which are free from x, y and z. Okay. So let us write down the first equation now. What is the first equation? X plus 2y plus z is equal to 7. Next, x plus, there is no y there. That means what is the coefficient of y here? 0. 0 into y. But you should write down the term containing y. But you should write here 0 into y. Plus 3z is equal to 11. Next one is 2x minus 3y. Here also z is missing out there. That means here it is plus 0 into z, which is equal to 1. So all the constant terms which are free from x, y and z are on the right hand side. So it's right. So now this is equation 1, this is equation 2 and this is equation 3. Now let us write down the coefficient matrix. Let capital A is equal to, what is the coefficient matrix here? So you have to write down the coefficients of x, y and z from the first equation. What are the coefficients of x, y and z from the first equation? It is 1, 2, 1. You write here 1, 2, 1. And in the second row, what will you write? That is the coefficient of x, y and z from the second equation. That is, what is the coefficient of x? 1. Coefficient of y here is 0. Coefficient of z is 3 here. Okay, that is 1, 0, 3. Next, in the third row, you will write down the coefficient of x, y and z from the third equation. So what are the coefficient here? Coefficient of x is 2. Coefficient of y here is minus 3. Coefficient of z is 0 out here. Is that clear now? So this is the coefficient matrix. Next, which is the unknown quantities out here? That is your x, y, z. Let capital X is equal to small x, y, z. That is your column matrix. And let C is the constant matrix. That is also the column matrix. That is, it is 7, 11, 1. Now you should write down these linear equations in terms of matrix equation. So what is the matrix equation here now? Therefore, the matrix equation is AX. This matrix A should be multiplied by matrix X. This matrix A should be multiplied by matrix X, which is equal to, that is your constant matrix. So I think you have understood it. Okay. Now next you have to get the matrix X. X is equal to, when this A is taken to the right hand side, what does it become? It is A inverse C. Now we have to get A inverse, that is inverse of the matrix A. You should get the inverse of the matrix A. Is that clear now? So let us write the matrix A. What is A matrix out here? A is equal to, this is 1, 2, 1. Then next 1, 0, 3. 1, 0, 3. Next one is 2 minus 3, 0. 2 minus 3, 0. So first of all, you have to check whether the inverse of the matrix A exists or not. Whether the inverse of the matrix A exists or not. Okay. So in that case, you have to find out det A. So det A is equal to, how can you find out det A? That means you can expand it. If you get det A, you can expand that matrix A, because this matrix A now is converted into determinant form, isn't it? Now you can expand it. So expand it with respect to the first row, plus minus plus. Now it is converted to determinant. Now we can expand it, plus minus plus, plus 1 within bracket, delete the row and the column through the element 1. So this remains 0, 3 minus 3, 0. So it is 0 minus minus plus 3 3s are 9. Is that clear? Next is minus 2. Now within bracket, delete the row and the column through the element 2. That means first row and second column are deleted. What remains? 1, 3, 2, 0. That means cross multiply 1 by 0. 1 into 0 is 0. Then minus 6. Then minus 6, right? Then comes what? Then comes plus 1. Plus 1 within bracket, delete the row and the column through the element 1. That means first row and third column are deleted. What remains? 1, 0, 2, minus 3. So 1 into minus 3 is minus 3 minus 0. Is that clear to all of you? So next. So or det A is equal to, now you can simplify it, 1 9s are 9. Okay, minus and minus plus 12, plus 12, then the last one is plus and minus, minus 3, minus 3. Okay, that is 1 9s are 9, minus and minus plus 12, then last one is plus and minus, minus 3. So or det A is equal to, it is 18. 12 plus 9 is 21, 21 minus 3 is 18, which is not equal to 0. That means A inverse exists. That is, the matrix A inverse exists. Now how can you get the matrix A inverse, that is inverse of the matrix A? How can you get the inverse of the matrix A? Now you should find out the cofactors of each element of the matrix A. You know how to get the cofactors of each element of the matrix A. Okay. So now this one, it can be written as capital A11. What is capital A11 actually? This represents the cofactor of the element belonging to the first row and first column. You know that. That is 1. Right? That is, you have to get the cofactor of this one. You have to consider the sign. How can you consider the sign? Minus 1 whole to the power 1 plus 1. Now, delete the row and the column through the element 1. First row and first column are deleted. What remains? 0, 3, minus 3, 0. Write it here. 0, 3, minus 3, 0. Okay, or this is a11 is equal to, this is minus 1 whole square is plus 1. You don't have to write it. Now cross multiply, it is 0, so it is minus into minus plus 9, which is equal to 9. That means we got a11. Okay, next you have to find out a12. What do you mean by a12? Cofactor of the element belonging to the first row and second column. Which is the element here belonging to the first row and the first column? First row and first column, that means 2. You should get the cofactor of these 2. Is that clear? First of all, consider the sign, minus 1 whole to the power 1 plus 2. Now delete the row and the column through the element 2. First row and second column are deleted. What remains? 1, 3, 2, 0. Write it here. You should write it as a determinant form. 1, 3, 2, 0. 1, 3, 2, 0, right? Which is equal to, what is minus 1 whole cube? That is minus 1. That is minus, and within bracket there will be, so what will you write here? What will you write here? 1 zeros are 0, 1 zeros are 0, then minus 6. Then it is minus 6, right? So 0 minus 6, which is equal to 6 only. So I think you have understood it. So next one is a13. Now how can you get a13? Let us consider the sign first. How can you get the sign? Minus 1 whole to the power 1 plus 3. Now this a13 means you have to get the cofactor of the element belonging to the first row and the third column. First row and the third column. That means 1. Okay. So we have considered the sign. Now get the cofactor of this 1. Delete the row and the column through the element 1. That means first row and third column are deleted. What remains? 1, 0, 2, minus 3. 1, 0, 2, minus 3, which is equal to, what is minus 1 whole to the power 1 plus 3? That is 4. That is plus 1. So plus 1, usually we don't write it. Expand this determinant. Minus 3 minus 0, which is equal to minus 3. That is, what is the value for capital A13? It is minus 3. Next, what is to be calculated? What is to be calculated next? Cofactor of next element. That means capital A21. It is capital A21. First, consider the sign, minus 1 whole to the power 2 plus 1. That means A21 means cofactor of the element belonging to the second row and first column. Element belonging to the second row and first column. That means 1. You have to get the cofactor of 1. So delete the row and the column through the element 1. And this second row and first column are deleted. What remains? 2, 1, minus 3, 0. What remains here? 2, 1, 2, 1, minus 3, 0. Minus 3, 0. Okay? This is 2, 1, minus 3, 0. Right? So now, which is equal to, what is minus 1 whole cube? That is your minus. Minus within bracket, 2 zeros are 0. 2 zeros are 0, minus to minus, plus 3, which is equal to, this is your minus 3. Is that understood? So you can copy it. Now we will find out the cofactor of the next element. Now let us find out the cofactor of the next element. Okay. So next element here is A22. A22 is equal to, now first of all consider the sign. How can you get the sign? Minus 1 whole to the power, it is 2 plus 2. Now what is A22? What does it mean? You have to get the cofactor of the element belonging to the second row and second column. Second row and second row, that means 0. You have to get the cofactor of 0. Now delete the row and the column through the element 0. Second row and second column are deleted. Second row and second column are deleted. What remains? 1, 1, 2, 0. It is 1, 1, then 2, 0. Okay. So let us simplify it. Which is equal to? Which is equal to next? It is minus 1 whole to the power 4. You know that it is plus 1. So usually we don't write plus 1. Now expand this determinant. That is 0 minus 2. Which is equal to minus 2. Understood? Next one, let us write down A23. A23 means cofactor of the element belonging to the second row and third column. Second row and third column, that means 3. You have to get the cofactor of 3. Okay, let us consider the sign first. -1 whole to the power 2 plus 3. Okay, now delete the row and the column through the element 3. Second row and third column are deleted. Okay, what remains? 1, 2, 2 minus 3. 1, 2, 2 minus 3, which is equal to, what is -1 whole to the power 5? That is your minus, and within bracket this second order determinant, you can expand it further. What do we get? 1 into minus 3, then comes minus I. 2 to 4. So which is equal to, that is your 7. Is that clear to all of you? So now we will write here, that is A11, A12, A13, because we can use this value. So what was data? Data is equal to 18. Data is equal to 18. Data is equal to 18. What is A11? A11 is 9. A11 is 9. What was A12? A12 is 6. A12 is 6, right? And what is A13? Is minus 3. A13 is equal to minus 3. Because I'll rub it. I will rub it, that's why I'm writing it there. You don't have to write it. Okay? So data is equal to 18. A11 is 9, A12 is 6, and A13 is minus 3. Is that clear to all of you? So you can copy it. Now we will find out the cofactor of each element of the third row. Okay? So let us find it. Cofactor of 2, minus 3 and 0. Okay? Now that is, you should find out A31. Now what is A31? Cofactor of the element belonging to the third row and first column. Third row and first column, that means 2. You have to get the cofactor of what? 2. First consider the sign. -1 whole to the power. How can you consider the sign? -1 whole to the power, this suffix 3 plus 1. And now you have to delete the row and the column through that element belonging to the third row and first column. Third row and first column, that means 2. Delete this third row and first column. What remains? 2103. 2103, which is equal to, what is -1 whole to the power 4? That is your plus 1, right? Now expand this determinant. How can you expand it? 2 3s are 6 minus 0 1s are 0. 2 3s are 6 minus 0 1s are 0, which is equal to 6. Okay? Next, you have to find out A32. What is A32? Cofactor of the element belonging to the third row and second column. Third row and second column. That means minus 3. Consider the sign first. -1 whole to the power. -1 whole to the power 3 plus 2. Now delete the row and the column through the element belonging to the third row and second column. That is minus 3. Delete the third row and the second column. What remains? 1113. 1113, which is equal to, now let us simplify it. What is -1 whole to the power 5? Minus, then expand it. 1 3s are 3, then write down minus always. So 1 1s are 1, which is equal to -2. Right? Now let us find out the cofactor of the next element, that is A33. Consider the sign first. -1 whole to the power 3 plus 3. A33 means element or cofactor of the element belonging to the third row and third column. Third row and third column, that means 0. Delete the third row and third column. What remains? 1 2 1 0. So it remains 1 2 1 0, which is equal to, now expand it. What is -1 whole to the power 6? It is plus 1. -1 whole to the power even number is always plus 1. So plus 1 usually we don't write it. Now expand this determinant. 1 zeros are 0, -2, which is equal to, this is your -2. So we have got all the cofactors of the elements of matrix A. Now let us assume the B matrix. Let B be the matrix whose elements are the cofactors of the elements of matrix A. Right? So let us write down here, let B be the matrix. Let let capital B be the matrix. Let capital B be the matrix whose elements are the cofactors, whose elements are the cofactors of the elements of matrix A. Of matrix A. त अब यो B matrix मा चाहिँ के हुन्छ भन्दाखेरि यो जति पनि A matrix मा एलिमेन्ट्स हरु छन् ती एलिमेन्ट्स को के हुन्छ कोफैक्टरहरु हुन्छ कुन चाहिँ matrix मा B matrix मा ठीक छ so B is equal to let us write here B is equal to A11 A12 A13 A21 A22 A23 then comes A31 A32 this is your A32 then A33 is that clear to all of you? Let us write here A21 also. What is A21? Because we will rub it. What is A21 is equal to minus 3. A21 is equal to minus 3. What is A22? Minus 2. A22 that is your minus 2, right? A22 is minus 2 and A23 is 7. A23 is 7. Okay. Now we will rub it. So now let us write down this matrix B. So B is equal to, now you tell me what is the value for A11. What is that? A11. A11 here is, this is 9. A12 is 6. A13. What is A13 here? That is your minus 3. What is A21? That is also minus 3. What is A22? Minus 2. What is A23? That is your 7, right? A23 is 7. So it's correct. Next, what is A31? Is 6. Next, what is A32? Minus 2. A32 is minus 2. And what is A33? That is also minus 2. We have got this matrix B. Now, what is to be determined now? You have to determine the adjoint of the matrix A. That is ADJ, it is also known as adjugate. I told you already, isn't it? So how can you define adjoint of A? It is the transpose of B. That is, which is equal to B transpose, right? So, or ADJ A is equal to, now you can transpose this matrix B. That means change rows into columns and columns into rows. That means this first column becomes the first row. 9 minus 3, 6. Next, this second column becomes the second row. 6 minus 2 minus 2. Next, that third column becomes the third row here. Minus 3, 7, minus 2. So this is your adjoint of A. So now what is to be calculated? You have to find out A inverse. You know the formula for A inverse, isn't it? A inverse is equal to, what is it? 1 upon det A into ADJ A. That is the matrix adjoint of A. So let us write down A inverse now. So what is A inverse out here? What is A inverse now? So A inverse is equal to, what is 1 upon det A? 1 upon 18. And what is ADJ A? What is that? What is that ADJ A now? You can copy it. 9 minus 3, 6. Then 6 minus 2, minus 2. Then minus 3. Then 7. Then write down minus 2. Is that clear to all of you? So this is your A inverse. Now we have to calculate. Now what is to be calculated now? So you have to calculate the matrix capital X. So you know how to calculate this matrix X. You know that, isn't it? So we have written the relation out there in the previous step. The relation was, so what was the relation? The relation was, since capital X is equal to A inverse C, right? capital X is equal to A inverse C, or capital X is equal to A inverse, just now we got it. What is A inverse? 1 upon 18, and then what is A inverse? 9 minus 3 is 6, 6 minus 2 minus 2, and minus 3, this is your minus 3, 7, and this is minus 2. And what was the constant matrix C? That is 7, 11, 1. This is 7, 11, 1. I think you have understood it. So you can copy it. Copy this one. And then we have to simplify it. Okay? Now let us simplify it further. You can multiply these two matrices. For the first matrix, 3 columns. For the second matrix, 3 rows. Number of columns is equal to number of rows, so you can multiply them. Okay? So, or capital X is equal to 1 upon 18. Now multiply these two matrices now. First row by first column. Corresponding elements should be multiplied. 9 sevens are 63. Minus 3 into 11, minus 33. Plus 6 ones are 6. Right? Now again, second row by first column. Corresponding elements should be multiplied. 6 sevens are 42, minus 2 into 11, minus 22. This is your minus 2. Is that clear to all of you? Next, third row should be multiplied by this first column. Minus 3 into 7, minus 21, plus 11 sevens are 77, minus 2 into 1 is minus 2. So we have simplified it. Now again you have to simplify within third bracket, that is within matrix sign. You can simplify it further. Okay, so let us simplify it. Or capital X is equal to 1 by 18. Now within matrix sign, plus same sign, add them. 63 plus 6 is 69, minus 33, right? Then 42, it is 42 minus, what is 22 minus 2? That is minus 24, right? Next, 77, write down 77 first, and then minus 21 minus 2 is minus 23, same sign, you can add them, minus 23. Is that clear now? So, or capital X is equal to 1 upon 18. Now it is, what is 69 minus 33? It is 9 minus 3 is 6. 6 minus 3 is 36. 42 minus 24. 12 minus 4 is 8. This is 3 minus 2 is 1. 18. 77 minus 23 is 7 minus 3 is 4. And 7 minus 2 is 5. So this is the column matrix. So all the elements of the column matrix must be multiplied by the scalar multiplication, that is 1 by 18. Or you can write here capital X. Instead of capital X, you write down the column matrix, that is XYZ, and then multiply all the elements in the matrix by 1 by 18. What do we get? 1 by 18 and 36, 18 twos are 36. 1 by 18 into 18, 18 gets cancelled, you will get 1. Then 18 threes are 54. Now these are the equality of two matrices. So from the definition of the equality of two matrices, you can equate the corresponding elements. That means you can equate X is equal to 2, Y is equal to 1, and Z is equal to 3. So this is the correct answer. I think it's correct. X is equal to 2, Y is equal to 1, and Z is equal to 3. So this question is very, very important. So in the next higher secondary examination, that is in 2021, this type of question is very, very important. Both Cramer's rule, solving by Cramer's rule, and solving by matrix inversion method. So you may get either Cramer's rule or matrix inversion method. So you have to practice it at home. Okay, so we'll do the next question now. And now we will do the question from HS 2017. So this question carries 2 marks only, right? So in this case, 1B number 1, so that you have to show that this given matrix A is proper orthogonal matrix? Okay, so first of all you should know orthogonal matrix. I haven't told you about this proper orthogonal matrix. Okay, so what is orthogonal matrix? First of all you should understand what is orthogonal matrix. Suppose there is a matrix A, there is a square matrix A of order n. That means n rows and n columns. Suppose there is a matrix A, square matrix A of order n, that is n rows and n columns. So if you can find out A dot A transpose is equal to A transpose dot A is equal to I, then this is known as orthogonal matrix. So here what is A? A is a square matrix of order n, that is n rows and n columns, right? So if you can find out A dot A transpose is equal to A transpose dot A is equal to I, then this is orthogonal matrix. यसलाई हामी के भन्छौं? orthogonal, यसलाई भन्छौं हामी orthogonal matrix भनेर भन्छौं. This type of matrix, if you can prove A dot A transpose is equal to A transpose dot A is equal to I, then you can say that A is orthogonal matrix. Now in this case you have to prove proper orthogonal matrix. So if you can find out det A is equal to 1, then this is known as what? Proper orthogonal matrix. Proper orthogonal matrix. यदि हामीले A dot A transpose dot A is equal to I prove गर्यो भने त orthogonal matrix भनिन्छ यसलाई. फेरि हामीले det A is equal to 1 prove गर्यो भने त्यसलाई के भनिन्छ रे? Proper orthogonal matrix. But if you prove det A is equal to -1, then this is known as what? Improper orthogonal matrix. This is known as what? Improper orthogonal matrix. Then this is known as what? Improper orthogonal matrix. So you have understood this definition. So what is an orthogonal matrix? A square matrix A of order n is known as orthogonal matrix if A dot A transpose is equal to A transpose dot A is equal to I, and if det A is equal to 1, then this is known as proper orthogonal matrix. Otherwise, if det A is equal to -1, then it is known as improper orthogonal matrix. So you should understand this definition. Okay, so we will apply this definition in this problem. So is that understood now? So let us do this problem now. So let us find out first A dot A transpose. Therefore A dot A transpose is equal to, here A is 1/3. What is A is 1/3? Then what is A here? -1, 2, -2, -2, 1, 2, then 2, 2, 1. This is the first. This is the matrix A. Now find out A transpose into 1/3. What is A transpose now? Change rows into columns and columns into rows. Now this first column becomes the first row. -1, -2, 2. Then it is 2, 1, 2. Then -2, 2, 1. Is that clear to all of you? So next, which is equal to, now you can multiply these two matrices. So 1/3 into 1/3 is 1/9, right? And now next, you have to multiply these two matrices, first row by first column. You know how to multiply them, isn't it? So it is -1, corresponding elements should be multiplied. You know that. -0 minus +1, +4, +4, right? Then first row by second column, +2, +2, -4. You know that, isn't it? You know how to multiply the two matrices. So first row by third column, -2, +4, -2, right? This is the first row. Is that clear? Next, second row by first column, -0 minus +2, +2, this is -4, right? Next, second row by second column, -0 minus +4, +1, +4, you know that. Again, second row by third column, right? -2 into 2, -4, +2, plus this is 2 ones are 2, right? And next, third row by first column. What is that? 2 into minus 1, minus 2, plus 2 2s are 4, minus 2. Next, third row by second column, minus 4, plus 2, plus 2. Then third row by third column, 2 2s are 4, plus again 2 2s are 4, plus 1. So this is the multiplication of the two matrices. Is that clear? So which is equal to 1 by 9? 1 by 9. Now you can add them. 1 plus 4 plus 4, that is 9. This is 0, 0, right? 4 minus 4, 0. This is also 4 minus 4 is 0. Second row, 4 minus 4 is 0. This is your 9. 4 plus 1 plus 4. This is also 0. And next third row is 4 minus 4 is 0. Minus 4 plus 4 is 0. And this is 9. Is that clear? Now all the elements of the matrix will be multiplied by that scalar multiplication, that is 1 by 9. So which is equal to 1, 0, 0, 0, 1, 0, 0, 0, 1. So which is equal to, this is I. So we proved that A dot A transpose is equal to I. Okay. Now we have to prove again A transpose dot A is equal to I again. Right. So let us prove A transpose dot A now. A transpose dot A. Right. Now first matrix will be A transpose, then A, which is, what is A transpose now? 1/3. Now transpose the matrix A. First column now becomes first row. Minus 1, minus 2, 2, then 2, 1, 2, right? Third row becomes third column becomes third row out here. Minus 2, 2, 1, then again into 1/3. You copy that matrix A, 1/3, then minus 1, 2, minus 2, okay, minus 2, 1, 2, right, then minus 2, 2, 1. Oh, that is wrong. This is minus 2, 2, minus 2, minus 2, 1, 2, then it is 2, 2, 1. Is that clear? Minus 1, 2, minus 2, minus 2, 1, 2, then 2, 2, 1. And this is your minus 1, minus 2, 2, 2, 1, 2, 2, 1, 2, and then minus 2, 2, 1, right? Okay. So now multiply this 1/3, 1/3, that is 1 by 9. Again multiply these two matrices now. Again multiply these two matrices. Minus into minus, first row by first column. Minus into minus plus 1, minus into minus plus 4, plus 4, right? Again first row by second column. Minus 2, minus 2 ones are minus 2. This is plus 4. Next first row by third column. Plus 2. Minus 4 plus 2, right? Next second row by first column, minus 2, minus 2 plus 4. Next second row by second column, 4 plus 1 plus 4. Next second row by third column, minus 4 plus 2 plus 2. Is that clear? So next one, what will you write? The next one, third row by first column, minus into minus plus 2, and then 2 into minus 2, minus 4 plus 2. Next, third row by second column, this is minus 4 plus 2 plus 2. Then again third row by third column, minus into minus plus 4 plus 2 2s are 4, then it is plus 1. Is that clear? So which is equal to 1 by 9? Which is equal to 1 by 9, right? Then you can add all those numbers. 1 plus 4 plus 4, that is 9. This is 9. Minus 4 plus 4, that is 0. This is also 4 minus 4 is 0. Is that clear? Next, this one will be 4 minus 4 will be 0. 4 plus 4 plus 1, 9. That is also 0. 4 minus 4. This is also 4 minus 4, 0. This is also 4 minus 4 is 0. And this is 9. Now multiply all the elements of that matrix by scalar multiplication 1 by 9. So what do we get? This is your 1, 0, 0, 0, 1, 0, and this is 0, 0, 1, which is equal to, this is I. So we got this I. That means A transpose dot A is also I. Got it? So now we have proved that A dot A transpose is equal to A dot A transpose is equal to A transpose dot A is equal to I. That means the matrix A is an orthogonal matrix. Okay, so you can write here, since A dot A transpose is equal to A transpose dot A is equal to I, therefore the given matrix A, the given matrix A is an orthogonal matrix, is an orthogonal matrix, is an orthogonal matrix. So we have proved that this given matrix A is an orthogonal matrix. Now what is to be proved? अब हामी के प्रुभ गर्छौं? अब हामी प्रुभ गर्छौं यो चाहिँ एउटा कस्तो खाले म्याट्रिक्स हो भनेर, orthogonal कस्तो खाले orthogonal matrix हो, proper orthogonal matrix. So in that case you have to find out det A. Okay, so now what is the matrix A? Again write down the matrix A. A is equal to 1/3 minus 1 2 minus 2 minus 2 1 2, and this is 2 2 1, right? Now what will you do? Multiply all the elements by 1/3 first. Before you convert this matrix A into det A or determinant of A, let us first multiply all the elements by 1/3. Okay, so matrix मा चाहिँ एउटा के छ भन्दा matrix र determinant मा एउटा के फरक छ भन्दा फेरि मैले अस्ति पनि भनेको थिए तिमीलाई, यो matrix को जति पनि elements हरु छन् यहाँ त्यो सबैलाई यो 1/3 ले मल्टिप्लाई गर्नुपर्छ, तर determinant मा त्यस्तो हुँदैन. Determinant मा चाहिँ के हुन्छ भन्दा फेरि either element in the first row should be multiplied by 1/3, or elements in the second row will be multiplied by 1/3, or element in the third row will be multiplied by 1/3, or it may be elements in the only elements in the first column will be multiplied by 1/3, or elements in the second column, only elements in the second column should be multiplied by 1/3, or only elements in the third column will be multiplied by 1/3 in that case. But in case of matrix, all these elements should be multiplied by 1/3. So first of all multiply all the elements of the matrix by 1/3. That means A is equal to, how much is it? Minus 1/3, 2/3, minus 2/3, minus 2/3, 1/3, 2/3, 2/3, 2/3, and this is 1/3. Is it correct? This is the given matrix. It is multiplied by 1/3. Okay, minus 1/3, 2/3, minus 2/3, minus 2/3, 1/3, 2/3, 2/3, 2/3, 1/3. Okay, now let us convert into determinant form. Now let us write det A. Now it is converted into determinant form. Okay, minus 1/3, 2/3, minus 2/3. Next, minus 2/3, 1/3, 2/3. Next, 2/3, 2/3, and it is 1/3. Okay, so therefore det A is equal to, now what will you do? You have to take common from each and every row. From each row you have to take common 1/3. From the first row you take 1/3 common, from the second row you have to take 1/3 common, from the third row you have to take 1/3 common. Okay, so in case of determinant, from each row or each column you have to take common. Okay, so 1/3, 1/3, 1/3, that is 1/27. Then it will be minus 1 2 minus 2, minus 1 2 minus 2, then minus 2 1 2, right? Minus 2 1 2, then 2 to 1. Then this will be 2 to 1. So I think you have understood it. Is that clear? Now you can expand it. Det A, keeping 1/27 as it is, therefore det A is equal to 1/27. Now expand it. Expand it with respect to the first row. Plus minus plus, right? So plus into minus 1, that is minus 1. Now delete the row and the column through the element minus 1. What remains? 1 2 2 1, right? So 1 1s are 1, minus 4, then minus 2, minus 2. Okay, plus minus plus, so you should write minus 2 here. Delete the row and the column through the element 2. What remains? Minus 2 2 2 1. Minus 2 into 1, minus 2, then minus 4. Then comes what? Minus 2, right? minus 2, minus 2. Plus into minus, minus 2. Delete the row and the column to the element minus 2. That is first row and third column are deleted. What remains? Minus 2, 1, 2, 2. Minus 4. This is your minus 4, minus 2. Is that clear now? So which is equal to 1 by 27. So within bracket minus 3 into minus 1 plus 3. This is minus 6, minus into minus plus. 6 2s are 12. Right? And this is also minus 6, minus into minus plus 12. Is that clear? Which is equal to 1 by 27 into, add those numbers. 12 plus 12, 24 plus 3 is 27. So which is equal to 1. Since det A is equal to 1, this given matrix A is a proper orthogonal matrix. Okay. Since det A is equal to 1, therefore the given matrix A, therefore the given matrix A is a proper orthogonal matrix, is a proper orthogonal matrix. So it is proved. So I think you have understood it. So we'll do the next question now. Now we are doing HS, the question paper from HS 2020, and this question carries 2 marks. Okay, now 1B number 1. So given here is, if 2A plus B transpose is equal to, second order matrix is given 2 5 10 2, and 2B plus A transpose is given, which is equal to 1 8 4 1, then you have to find out the value of the matrix A. So what is matrix A? You have to get matrix A. Now in the first equation, this is only A is given, transpose is with B. So keep this equation as it is. Okay. Now in this case, you have to make this A transpose as A and this 2B as B transpose, so that you can solve these 2 equations to get the matrix A. Right. So first equation, keep it as it is. So here given is 2A plus B transpose is equal to 2 5 10 2. Right. Now in this case, you should know the properties of transpose of a matrix. I told you about that one also. That is, if you have A plus B transpose is equal to, what is the formula here, or what is the property here? It is A transpose plus B transpose. You should know it. That is, transpose of the sum of the 2 matrices is equal to sum of their transpose. Like A plus B transpose is equal to A transpose plus B transpose. You should know it. And again, you may write this one also. A minus B whole transpose is equal to A transpose minus B transpose. Okay. And the next one is, you can write A transpose whole transpose is the matrix A itself. That is, A transpose whole transpose is equal to matrix A itself. Okay. So in this case, we should use these 2 properties. Right. Now let us write down the second one. This is the first one. Let us mark it as 1. What is the second one? That is 2B plus A transpose is equal to 1 8 4 1. Let us transpose both the sides here. Okay. Let us transpose both the sides. What do we get? 2B plus A transpose whole transpose is equal to, if you transpose left hand side, you should transpose the right hand side as well. Okay. So this is 1 8 4 1 whole transpose. Is that clear? So let us simplify it first. So now in this case, you can use the property here, 2B transpose, 2B whole transpose, 2B transpose plus this will be A transpose is equal to, so you have to transpose this matrix, given matrix. That means you have to change rows into columns and columns into rows. What do we get? Now first row becomes 1 and 4, and second row becomes second column. Your first column becomes first row 1 4, and this second column 8 1 becomes second row here, that is 8 1. Is that clear? Next, it will be 2b transpose plus, what is A transpose whole transpose? That is A, which is equal to, this is 1481. So this is your, so what is it now? This is number 2. So this is number 2. Okay. Now you have to solve these two matrices. You have to solve these two equations. That is equation number 1 and equation number 2. So now in order to get the matrix A, you have to make the coefficient of B transpose equal so that we can subtract it. Okay. So here, what is the coefficient of B transpose? It is 2. But what is the coefficient of B transpose here? It is 1. So multiply both the sides of equation 1 by 2. So what do we get? Therefore, multiply both the sides of equation 1. That is multiplying both sides of equation 1 by what? 2. Right? So what do we get now? By number 2. By 2. Multiplying both sides of equation number 1 by number 2. So what do we get here? 4a plus, this is 2b transpose, and you should multiply all the elements of the matrix by 2. What do we get? So what do we get? 2 2s are 4, 2 5s are 10, 2 10s are 20, 2 2s are 4. So we got this matrix, right? So I think you have understood it. So this is the new equation now. So this is equation number 3. Now you have to solve this equation number 2 and equation number 3. Okay. Now solving 3 and 2. Now solving 3 and 2. So let us write number 3 now. 4a plus 2b transpose is equal to what? It is 4 10 24. 24, right? And then write down number 2, that is, let us write A first, then plus 2b transpose, which is equal to 1481. 1481. Okay. Now let us subtract it. This is minus minus, this is also minus. Here 2b transpose gets cancels. What is 4a minus a? That is your 3a is equal to here. Write on the first matrix 4 10 24, then minus 1 4, this is 8 1. Is that clear? So let us simplify this right hand side now. So you can simplify this right hand side. So left hand side remains same. 3a is equal to, what is the first matrix here? 4 10 24. 4 10 24, make it plus sign. Multiply all the elements of the second matrix by minus sign. What do we get? Minus 1, minus 4, minus 8, minus 1. Is that clear? Next, or 3a is equal to, you can add those two matrices. 4 minus 1 is 3, 10 minus 4 is 6, 4 minus 1 is 3, 10 minus 4 is 6, 20 minus 8 is 12, and 4 minus 1 is 3. Okay. So, or what is a is equal to? Now 1 by 3 is taken, that is 3 is taken to the right hand side, becomes 1/3, and it is 3 6 12 3. Or what is the value for a now? What is the value for the matrix A? 1/3. It is the scalar multiplication of this matrix. All the elements of this matrix should be multiplied by 1/3. So what do we get? 1/3 into 3 is 1. This is 3 2s are 6, 3 4s are 12, 3 1s are 3. So this is the final answer. So what is the matrix A out here? It is in the first row 1 2, and in the second row it is 4 1. Is that clear to all of you? So we'll do the next question now. Now we will do objective type of questions. That is, this question carries 1 mark only. So you have to choose the correct option, and you have to write down the correct option in that blank box. Okay, so what is the question here? This is one number 6. if A is a square matrix, that is number of rows is equal to number of columns, and A square is equal to A is given, then I plus A whole cube minus 7A will be what? Is it A, B, C or D? You have to choose the correct option. Okay. Now therefore, what is given here? I plus A whole cube minus 7A, right? So which is equal to, it can be written in terms of I plus A into I plus A into I plus A. So whole cube means this I plus A is multiplied thrice, isn't it? So it is I plus A into I plus A, then minus 7A, which is equal to, now you know that, what is I dot I? This is your I. 1 into 1 is 1. Similarly, I dot I is I. Plus, what is I dot A? That is A. Plus again, what is A dot I? That is also A. Plus, what is A dot A? That is A square. So it is I plus A. Then this is your minus 7A. Is that clear? So which is equal to I plus A is 2A plus, again in the question it is given that A square is A. It is given that, isn't it? So you can write A instead of A square. So it is I plus A minus 7A, right? So which is equal to I plus 2A plus A is 3A. Then it is I plus A minus 7A. Clear? So which is equal to, now you can multiply these two terms. What is I dot I again? It is I plus I dot A, that is A, plus this constant 3. What is A dot I? That is A, that it is 3A plus 3A into A is plus 3A square, plus 3A square. Then you have to write minus 7A. It is just like your multiplication, isn't it? So is equal to I plus, this is 4A plus 3. What is A square actually? That is A. A square is A. And this is minus 7A, which is equal to I plus 4A plus 3A is 7A. Then this is minus 7A, right? 7A gets cancels, which is equal to I. So what is the value for I plus A whole cube minus 7A using A square is equal to A? So it is I. So which is the correct option? That is B is the correct option. You can put it out here. That is B. Is that clear? So we'll do the next question now. Now we are doing the next question, that is from HS 2017. That is question number 1, 2. This is also objective type of question. If the inverse of the matrix A exists, that means inverse of the matrix A exists, then the value of det within bracket A inverse is, which is the correct option? Is it A, B, C or D? You have to write down the correct option in this blank box. Okay. So let us take an example. Suppose let A given matrix be a square matrix, that is 1, 2, 3, 4, right? So let us find out det A first. So if you write det A, then it is converted into what? Determinant form. That is det A is equal to, what is it? What is det A is equal to? You can cross multiply it, 4 minus 6, which is equal to minus 2. That means A inverse exists. So let us find out A inverse now. Let us find out what A inverse. Okay. So you know how to get A inverse. That is A11 is equal to minus 1 whole to the power 1 plus 1. That is cofactor of the element belonging to the first row and first column. First row and first column. That means 1. So what is the cofactor of 1? We have considered the sign minus 1 whole to the power 1 plus 1. Now delete the row and the column through the element 1. That means it is 4. So it is 4 only. So which is equal to 4, right? Then comes A12. A12 means cofactor of the element belonging to the first row and second column. First row and second row. That means 2. Consider the sign minus 1 whole to the power 1 plus 2. Now delete the row and the column through the element 2. First row and second column deleted. What remains? It is 3. So this is minus 3. You know that, right? Next A21. Consider the sign first. Minus 1 all to the power 2 plus 1, that is cofactor of the element belonging to the second row and first column. Second row and first one, that means 3. Delete the row and the column through the element 3. Second row and first column deleted. What remains? 2. So which is equal to minus 1 whole cube is minus 1. So it is minus 2. Then comes a22. What is a22? Consider the sign first. Minus 1 whole to the power 2 plus 2. We have considered the sign. Now what is a22? What does a22 mean? It means that this is the cofactor of the element belonging to the second row and the second column. Second row and second row. That means 4. Take the cofactor of 4. Delete the row and the column through the element 4. That means 1. So which is equal to minus 1 to the power 4 is always 1. That means 1 1s are 1. Okay. So now write down, let हामी के लेख्छौं actually अब यो objective हो, let B be the matrix or लेखिरहनु पर्दैन. Actually what is B? B is the matrix whose elements are the cofactors of the elements of matrix A. Okay. So therefore capital B is equal to what is here? A11, A12, A21. This is your A22, right? And that means B matrix is equal to, you may write within third bracket or within first bracket. It doesn't matter. Okay. So B is equal to what is A11? 4. What is A12? Minus 3. What is A21? Minus 2. What is A22? This is 1. Right? Is that clear to all of you? So next, what is adjoint of A? What is adjoint of A? That is your B transpose, right? So ADJ A is equal to what is B transpose in this case? Change rows into columns and columns into rows. Now first row becomes 4 minus 2 and second row becomes minus 3 1, right? That is your adjoint of A. Now we have got here data is equal to minus 2, right? We have got here data is equal to minus 2. So what is A inverse now? So A inverse is equal to what is the formula? 1 by data into ADJ A. 1 by data into ADJ A, or A inverse is equal to, this is your, what is data now? It is 1 upon minus 2, and what is ADJ A? It is 4 minus 2, and this is minus 3 1. So I think you have understood it. So what is A inverse is equal to, this is minus half, and adjoint of A is 4 minus 2 minus 3 1. Is that clear? Now we have to calculate. What is to be calculated or what is to be determined? You have to find out date of A inverse. That is date of A inverse, right? So here data is minus 2. So let us write it in the rough part. Data is equal to minus 2, right? So now date of A inverse. So first of all, A inverse is equal to, now this is the case of a matrix. So all these elements of the matrix must be multiplied by minus half first. Okay. So multiply by minus half. How much is it now? Minus 2. This is your plus 1. This is plus 3 by 2. And this is minus half. Right? Is that clear? That is all the elements of the matrix is multiplied by minus half. So we get minus 2, 1, plus 3 by 2, minus half, right? So what is date of A inverse? So you can convert it into determinant form now. Minus 2, 1, then 3 by 2. This is 3 by 2 and this is minus half. Is that clear now? So you can expand it further. So this is determinant, you can expand it. You can cross multiply it. Minus into minus plus 2 into half is 1. Then minus 3 by 2 into 1 is 3 by 2. So which is equal to 1 is 2. This is minus half. Which is equal to, you can write it as 1 upon minus 2. Which is equal to 1 upon, what is minus 2 here? That is date A. That is your date A. Okay. So what is date of A inverse is equal to 1 upon date A. So which is the correct options out here? That is C. C is the correct option. So you can write here C. Is that understood? So we'll do the next one now. So now this question is from HS 2018, right? This question is from HS 2018. This is very, very important problem. Okay. So this is from the objective questions. So number one is, if A is a square matrix of order 3 cross 3. A is a square matrix of order 3 cross 3 means 3 rows and 3 columns. Then the value of determinant of K or det of K or modulus of K, it is read as determinant or det of K into A, where K is a constant quantity, will be, is it A, B, C or D? Which is the correct option? You have to write there. So let us assume capital A as 3 cross 3 matrix. Okay. So this is A1, B1, C1, A2, B2, C2. This is your A3, B3, and this is your C3, right? Let us consider this 3 cross 3 matrix. Now, since you have to find out K into matrix A, so let us multiply both the sides by a constant K. That is, this is KA is equal to K. Then this is the matrix A1, B1, C1, A2, B2, C2, and this is your A3, B3, C3. Is that clear? Next, or KA is equal to, now this is the case of a matrix. You have to multiply all these elements of the matrix by K. So what do we get? So it is KA1, KB1, KC1, right? Then KA2, KB2, KC2. Is that clear to all of you? So all the elements of the matrix should be multiplied by K. That is KA3, KB3, KC3. Is that clear to all of you? Now you have to find out the determinant of Ka or det of Ka. So its notation is this one. Now convert this matrix into determinant form. So it is Ka1, Kb1, Kc1, Ka2, Kb2, Kc2, now Ka3, Kb3, and then this is Kc3. Is it clear to all of you? Now let us simplify it. So therefore determinant or det of Ka is equal to, now in case of determinant you have to take common from each row. That is, you should take common from the first row, second row and third row. From the first row K is common, second row K is common, third row is K is common. K into K into K, what is it? K cube. Then this determinant is A1, B1, C1, A2, B2, C2, A3, B3, C3. Now we have changed that matrix into determinant form. Okay. So this will be Ka is equal to K cube, and this is determinant of A. Okay. So this is the correct option. So which is the correct option out here? That is K cube and det of A. That is C is correct. Okay. That means this C is correct. So write down the correct option in the blank box. That is C is the correct option. Okay. So now if this question is like this, so what will be the correct option? Okay. So if A is a square matrix of order 2 cross 2, if it is given only 2 cross 2, that is 2 rows and 2 column matrix, then the value of within mod or det of Ka will be, which is the correct option in that case? You will have only 2 cross 2 matrix, that is second order matrix. Okay. So in that case, B option will be the correct answer. I think you have understood it. So this is your homework. Okay. So you can copy it. So I think you have copied it. Now this is your homework. Write down the homework. Now I'll change this question, right? Now I am changing this question. That is your homework, right? So which is the correct option? You have to write it. If A is a square matrix of order what? 2 cross 2, then the value of determinant or date of Ka or within mod K will be, which is the correct option, write it here. Okay, so I gave you the hint also. B will be the correct option in that case, but you prove it. I just showed you an example, isn't it? Just now I showed you one example of square matrix about a 3 cross 3. So likewise, you can do this problem and choose the correct option and write down that correct option in that blank box. Okay, so this is your homework. So I think I've understood it. So you revise all the problems that we did today. Okay, so in the next class we'll do new chapter. Okay, so you can copy this question and you do this as homework.